Okay, so I'm going to go over today's homework, and you'll notice that I have these switched on accident, so I'll go over that in a second. But the first example says sleepless nights. How much sleep do high school students get on a typical school night? An interested student designated a survey to find out. To make the data collection easier, the student surveyed the first 100 students to arrive to school on a particular morning. These students reported that on average, they got 7.2 hours of sleep. What kind of sample did the student obtain is the first question. Well, this is for sure the type of sample that the student obtained is a convenience sample. This is a convenience sample. And the reason that I know that it's a convenient sample is because they stood out in front and gathered data from the first 100 students to arrive to school. Explain why this sampling method is biased. Well, here is the deal with this one. Convenience sampling always leaves out part of the population, but on top of that, this is the population of the first 100 students that that arrived to school, and that's going to likely produce a lower than normal average since they probably slept less time. They got there early, right? So they probably had less sleep. So that'll probably be a little bit higher number in the average population, especially if you think about West Hills High School. Some people start second period, so they might be getting more sleep than you. So that's why this is bias. For number 7, we have an online poll. The question was asked, should drivers be banned from using all cell phones? And then from there, the results were that 85 said yes and 15 said no. This, by the way, was an online vote. Like you could go online to do that. That is known as a voluntary response. That's a voluntary response sample. It's likely that it would actually be a lot lower than this 85% that said yes, because again, only people with the voluntary response will always be only with people with strong opinions will weigh in. So maybe these people are scarred in some way. There was an accident that they were involved in with cell phones, but needless to say, it's likely to be a lot lower with voluntary response. Okay, moving on to number 8. Number 8 is a great problem. So here is kind of the heart of what we're going to do with simple random samples. So in this one, you have, do you trust the internet? You're going to take a sample from these students that you have below. It looks like there are 40 different students, so I numbered them. So Anderson is 0, 1. And I numbered them all the way to the last one of 40 because there are 40 different students in this sample. Okay, so you'll see I would number them 0, 1 through 40. And then I'm going to use the table from there. It says to use table line 107. So I'm going to pull up the table right now so you guys can see it. I'm going to zoom in a little bit. And we're going to use line 107. Oops, zoom out a tiny bit. So line 107 is right here. So you see me going through the process of actually listing the numbers. So that you guys can see where I'm getting these numbers, I took 82. We're taking them in 2-digit chunks. 82, nope, that didn't work. So I wrote that down. 73, no. 95, nope, didn't work. 78, nope. 90, nope, not in my sample. Up 20 though, 20 is. So you can see 20 is the first person that I'm gonna sample. I continued to do that. So you can see I wrote down the numbers 80, 74, 75, 11. There's my next person. So all I did was run along line 107. Remember that if you run out of line, like at the end, I might be out of line, you just go down to the next, to line 108 and then start there with 60, okay? Okay, which is what I did. You can actually see it here. I have 60, then 94, then 07. 60, 94, 07, right there is where I got to end. And then, so I labeled them, I went to the table, and then the last thing that you do is you actually list them. You're gonna list the actual values, which is what I've done. I've listed who those are. Number 20 happened to be Johnson. So number 20 was Johnson. Johnson right there. Then I have, number 38. Number 38 was Washburn, and so on and so forth. Okay, so then we pop down to number 9. You get one more of those. Okay, you get one more of those. There are 33 people in this sample. And we're gonna take a simple random sample of 3. We're only gonna take a simple random sample of 3. And it says to start at line 117. So again, I'm gonna number them 0, 0, or I'm sorry, 0, 0, 1. Let me see, 0, 1, how many are there? There must be 34 then. 3 apartment complexes. So there must be actually 34. You can number them 0, 0 through 33 or 0, 1 through 34. Either one would be fine with me. Okay, so now I'm going to actually go to line 117. So I'm going to show you guys that process again. On line 117, I'm right here, and you can see me taking them from here. So I have 38, 16. I actually got it on the second one, which is nice. There's one of them. Then I have 79, 85, 32. There we go. That one's within my range. Then I have 62, 18, and that's where I could stop. I actually didn't need to go any further than that. I've got my 3 for my sample. Okay, so then you have to, the last step is to, after you do that, figure out which one is number 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Farrington is my 16th. Okay. Okay. Last one, number 10, the table of random digits. It's very important for you to understand that these are completely random. So it says here, which of the following statements are true of the table of random digits and which ones are false? Briefly explain your answers. There are exactly 4 zeros in each row. No, these are completely random. There's no consistency in this table, okay? Each pair of digits has a 1 in 100 chance of being 0, 0. That is actually true. That's the chance. Now, does that mean that there's exactly a certain number of 0, 0s? No, but the chance of any 2-digit number being selected is 1 in 100. And by the way, those are 0, 0 through 99. That's 100 different digits. So yes, they have a 1 in 100 chance. The last one, the digits 0, 0, 0, 0 can never appear. That is not true. It is unlikely that those are going to appear, but the table is completely random. 0, 0, 0, 0 has just as good of a chance as 1, 1, 1, 1 has, which definitely can happen. It's going to be a 1 in 10,000 chance. And that is all for this.